All right, here is something I know the students I've taught haven't had before, but piecewise defined functions. So here is a piecewise defined function, and it looks kind of intimidating, but don't let it scare you. Again, look at little pieces of it. So what this is I think the easiest way to look at these and to think about these is with a table of values. So I'm just going to just start throwing in, anytime you have a function that you don't know what's going on, just start throwing in values. And if you look here, you know, you've got some things that look interesting. So it says x is less than -2 here. Well, so what it's doing is it's giving you three different rules to follow. If x is less than -2, you're going to use 2x. If x is between and including -2 and less than 1, you're going to use x squared. And if x is greater than or equal to 1, you're going to use 4 minus x. So let's say I gave you the number -4. All right. Well, -4 is less than -2, so you're going to use 2x. And so 2 times -4 would give you -8. Okay, so and you could just plot that. So what happens, you know, anything less than 2? What happens if I gave you -2? Well, if we wanted to plug in -2, now you've got to switch to this function, the middle one. And so you'd have -2 squared, which is 4. How about -1 and 0? And so we'll do both of those, and 0. Okay, well, -1 falls in this middle area too. And so that would be squared. So you'd have -1 squared, which is 1. And then 0 is also in that middle section. So that'd be 0 squared, which is 0. And then finally, anything beyond 1. So let's say I pick 1. Can we use that middle section? Well, no, because it's anything less than 1. So now we're switching to the bottom and using it. So if you plug 1 in, 4 minus 1 is equal to 3. And then, you know, 2, you would also use the same thing. So 4 minus 2, is 2. And so you just graph those just like you would normally. So these are just conditions to graph the different functions. So if you think about this, now what's happening, if I were to graph this, I'm just going to give you a rough sketch. And we're going -1, -2, -3, -4, 1, 2, 3, 4. Essentially what's happening here is, and I'll start with the middle part here, from -2 to 1, you're going to have a quadratic. Yeah, where 0 is 0, -1 is 1, and -2 is 4. So, you know, if you go 1, 1, 2, 3, 4, -2 is 4, is right here. Okay. And then 1 is 1. But here's the thing, when you get to 1, it's an open circle. So you got the middle part looks something like this. And the open circle is because of the less than 1. It doesn't include 1, but we'd end there. Okay, and then if you graph I'll do it in green. If you graph this left piece, that's the equation y equals 2x. So that's a line with a slope of 2. So we've got a couple points to make that happen. Or I guess we only have one, but -4, -8. So 1, 2, 3, 4. You know, 1, 2, 3, 4, 5, 6, 7, 8 would be here. And then -3 would be -6. So 1, 2, 3, 1, 2, 3, 4, 5, 6 would be that point. So we know we have a line that goes up here, and when it reaches 2, there's an open circle because it doesn't include 2. And so there's what the top one looks like. And then the other piece, the 4 minus x, that's also a line, but it's, and we'll do it in black, but it's for anything greater than or equal to 1. And so you start with 1 because it's equal to that. And we know 1 is 3. So 1, 1, 2, 3. So this function kind of jumps all of a sudden up to 3. And then one more point, I guess it's 2 and 2. So 1, 2, 1, 2. So it's a line like this. And heading down with a negative slope. And so that's what the piecewise function looks like as a graph and as a table. And hopefully my explanation's good. You might, I haven't spent much time plugging this into GeoGebra, but I know there's a way to do it. So maybe next time we'll make a video on how to do that. But it's almost easier, I guess, for me because I'm so practiced to just do it by hand, make a table and plot some values and know what I'm dealing with. I'm dealing with 2 lines and a quadratic. So best of luck. Hope this helps. Later.